Hello, welcome to this session on reverse engineering malware like a Jedi. My name is Axelle. I work with Fortinet on mobile malware and IoT malware. I'm also actually a VB enthusiast. I've been to quite a couple of VB conferences and always enjoying them. Today, let's directly jump to the topic, which is advanced tools for Android reverse engineering. I have selected 4 different tools: Dexcalibur, House, MobSF, and Quark. All of them are open source. You've got the links there. You can download the tool and use it. They are free. In the case of Dexcalibur, I know that there is a pro version on its way, but the community version remains, and you can use that if you prefer, of course. And also, we'll see a little bit the differences between all of these, but Quark has one particularity. It's the only static analysis tool. The other 3 are dynamic analysis. MobSF does a little bit of both, but Quark will only do static analysis. Also, what I wanted to say is that the goal of this presentation is not really to compare those 4 tools, because actually all 4 of them are really awesome. But the goal is rather to help you understand where you can use this tool or this other tool, how to use them, how to customize them. That's what we are going to discuss now. So, first topic, unpacking. Okay, this happens very often. You get a packed Android malware and you need to unpack it. You can do that statically, of course, but to be honest, to do some unpacking, sometimes dynamic analysis is easier in that case. All 3 tools, MobSF, Dexcalibur, and House, are actually front ends to Frida. So to do your dynamic analysis, you're gonna need Frida, you're gonna need an Android emulator, of course, and you will need the sample of the malware. In the case of MobSF, it automates quite lots of things, so you won't actually have to install Frida yourself or the malware on the emulator. In the case of Dexcalibur and House, it's more manual, and you have to do it, so it's kind of more obvious that you need all 3 elements to do the work. So this is MobSF, and we'd like to unpack this sample, Flubot. Flubot is a malware I got from 2021, and you get to this screen. So the screen, well, it's pretty nice, of course. I particularly like this one there, Android API. When you click here, because you see what the various parts of the code are doing. And this one, if you have a little bit of experience, it really smells unpacking, okay? Because it is doing a dynamic class loading. And it's awesome. You can click there and you automatically jump to the decompiled code. Okay, so this is pretty good. So this would be interesting if you wanted to do static analysis, but that's not what we want to do. I want to show you here dynamic analysis. So this is where we click Start Dynamic Analysis. So we get to this screen, okay, which is for dynamic analysis. So actually, if we want to unpack the sample, you've got to make sure that API monitoring is clicked. You actually don't need the other ones. You could leave them if you prefer. And then we will click on Start Instrumentation. And a button here will appear with Live API Monitoring, which is where we will click on. You don't see it, but I have an Android emulator, and I could also access the emulator through this part of the screen. That's maybe something I don't like that much with MobSF in the screens of dynamic analysis, is that when your screen is a bit small like mine, everything is a little bit too much in the column. But of course, if you've got a larger screen, it should probably be fine. So start instrumentation, and then jump to live API monitoring, and normally it should unpack, and we should see it unpack. There it goes. We've got it here. So let me explain a little bit in case you're not really used to unpacking on Android platforms. On Android, you've got Dalvik executables. If you want to load dynamically a Dalvik executable, you typically use a class which is called DexclassLoader. You construct an object of this class, and actually the constructor of this class takes as first argument the path to the Dalvik executable file that you want to load. So this means that actually this here, tli.json is not a JSON file, but actually a Dalvik executable file that we want to load. So this is actually the unpacked Dalvik executable for the sample. Unpacking is done. You just have to go on the Android emulator, go to this path, retrieve it, and now you can work on the unpacked sample. We've been doing some unpacking, now obfuscation. That's another common reverse engineering task. You get a sample with tons, for instance, of obfuscated strings. How are we going to deobfuscate? So let's have a look. So this is Dexcalibur, and we're going to create a new project to do some deobfuscation of a sample called KSApp. I'm going to upload the sample. It's this one. Select my emulator and click on continue. So this is a known bug. The creation of a project somewhat fails. So you just have actually to restart Dexcalibur in this current version 0.7.9. Reload the page, and actually you'll see that, well, it doesn't really, it actually completed. The project is created, KSApp, I'll do open there. And now it is starting to analyze the sample. So now this takes a little bit of time because it's got to do all the analysis. Okay, we're done. When you reach to the screen, you know you're done and you're ready to do some stuff on your sample. So in this particular case, we have here lots of hooks which are already preloaded for the sample and that we can use, enable, or disable on clicking the button on or off here. Those are interesting, but in our case, we want to do some deobfuscation. So we are going to actually need to put a hook on the doFinal method of the Cipher class. And I don't see it listed here, so we're gonna have to do it manually. So find class by name, it is called Cipher, let's do that. And there we see it. We go in the Cipher class and we look for one which is so doFinal, I said, yeah, this one exactly. It takes a byte array as input and a byte array as output. We are going to probe this one. Let's have a look at it. And that is, okay, the method. Okay, not exactly what I wanted to see. Let's go back to the dashboard with the hooks. And normally down there I have a custom hook for Cipher doFinal, and we can even customize it. Okay, so this is the Frida hook that you get. The code is not so easy to understand maybe at first, but you see that it calls here the doFinal function. And what I want basically to ensure is to see that the results of this doFinal, which will be the decrypted or deobfuscated version of strings. So I'm going to put here ret to be sure that it shows, and then I save my hook. Okay, and then we're going to launch our runtime analysis. So make sure that Frida server is running. It says that it is running over here, but I'll double check because sometimes it is wrong. In that case, it is wrong. So I go in my ADB shell, launch Frida, local tmp, and there it is. This time it is really running. I have an Android emulator. Oh, I nearly forgot one important thing. Well, I need to launch the malware, right? Okay. There, so I'm gonna install the malware on the emulator. Sign ks-app.apk. There it goes. So now everything is ready. I've got the sample, I've got Frida server which is running, and I have Dexcalibur. So now I can hit the run spawn key and I will see things coming. So actually we will be interested in anything that it does some decryption on, and we see as a result there, okay? And this is how we can do some de-obfuscation with Dexcalibur. Another task. This time you have an Android malware and you'd like to monitor the communication with the malware to any remote server, right? Again, pretty typical. So in this case, I like to use House. House is very good for that. So it's asking me for the emulator I'm using. So this is my emulator I'm using here. I can do select there. Then it's asking for the package of the malware, the name of the package of the malware. So I've got first to install the malware, which is eventbot in this demonstration, eventbot.apk. Then I'm going to list packages which are there and find it is there. So this is the name of the package. It doesn't have a very malicious name. I mean, it's a bit kind of obvious there, but that's in this case, this is the real name of the malware, okay? And then we'll head for the monitor section. So here, confirm. It says that. I think you can just hit the button refresh, and if it shows you that, you are good, and then you can go in monitor section. Make sure to enable, I most of the time enable everything, okay? Save and run, and refresh on, and then wait a little bit for things to pile on in those tabs, and especially in the HTTP tab. There we go. So we see here it is contacting Aura, Carla, Arbito, Arquitecto, or Aura Studio Legale Basili. And what is even better, because you could have got that with Wireshark, is that you know exactly which part of the source code is doing this call. And you see here, this is the standards API, open connection over here, but here, comlib sendpost, this is from the malware. So this one is going to be particularly interesting to investigate when you're doing, when you're reversing the code, okay? So there you go. This is an easy way to monitor the communication with the remote server. Let's discuss static analysis with Quark. So Quark, you get its usage this way. Notice especially this option there, -A, to feed in the APK or the Dalvik executable that you want to get analyzed. So we are going to do it over this Dalvik executable. Actually, this is the unpacked payload of Mockhow. Mockhow is a malware. It is packed. I unpacked it using, well, Dexcalibur, MobSF, or House, and you get this Dalvik executable. And now you think, okay, but what is this doing? Okay, where do I start? And this is where Quark is particularly interesting because it gives you an idea of what are the most interesting parts to investigate. So -A, and then I'm going to use labels because labels are kind of roots of rules to see where there are things which might be interesting. So there we go. And we get this output. So there's lots of things which are interesting, but we're going to focus a little bit on this second line there, where we see that there's a pretty high number of rules which are being triggered and which do something around SMS. And we see that at least one of these rules hits the maximum confidence of 100%. So what happens is that a rule, let me show you a rule. A rule is over here. Let's show this one. Okay, so for instance, for a crime, this is basically what we'll call a malicious behavior in a malware. This crime is send SMS. You need a permission. Here it hasn't been specified, never mind, okay? But if you need a permission for that, you can put it in your rule here. And then we set a list of APIs which need to occur for this crime to be triggered. And this is the Android API, which needs to be called to send an SMS message. For instance, here, send multi-part text message. So here, if we have 100%, it means that we are sure that at some point, one of the rules which is defined there does occur. So now we need to get a little bit more information about those rules and what it is actually really doing with SMS. So I'm going to use -S and focus only on rules which have 100% confidence. -S is for summary. And those are all the rules which have 100% confidence. So for instance, this one, we see the keyword SMS, this one here, this one as well, this one here, things like that. Let's have a little bit more details about this one, okay? So if we want details, it's not -S, it's -D. And I only want details for this rule, so I'm gonna put the name of the rule afterwards. And we don't need this. And we can run that way. So we see that it has a 100% confidence for this rule because we had no permission specified, so it's automatically a hit. And then the API, both of them occur. Well, one of them occur, both of them occur. They occur sequentially. And then also on the same parameter, okay? So this is why we get 100% of confidence. And we see it occurs in a class name com, q, and the method is d. So I go and see my decompiler, and we are automatically placed there in com, q, and d. There it is. And indeed, we see here, send multiple text message. So this is the phone number to send the SMS to, and this is the body. And also quite interesting, you can see that while it is sending SMS, here it is obviously turning off the ringer mode so that we don't have any kind of beep on the phone that it is sending out an SMS. So this is really very obviously a malicious part of the sample. So this is just an excellent way to begin. We already know that this sample of Macau is sending SMS to some external phone number, and that it is trying to do that in a stealthy way because it is setting the ringer mode to silent mode over there. Let's conclude this presentation. From the user point of view, the setup of Quark and MobSF is really easy, okay? You'll have no problem installing it. For Dexcalibur, it can get tricky, especially if you are using a Windows operating system. If that is your case, I think you'll probably need to use my Docker container, which is on GitHub, Cryptax, Android RE. You'll find it there, okay? But then once it is installed, Dexcalibur is really cool. I think it's my preferred tool because I understand intuitively exactly what I am doing. Oh, okay, I'm enabling this hook. I want it on, I want it off. I can modify a little bit the hook if I want to, and I really like that. But all tools are really good. So which tool are you going to use in which situation? Unpacking, actually, you can use any of those 3 tools. They work as well as each other. For network monitoring, I prefer House, but Dexcalibur and MobSF, of course, will be able to do it. Deobfuscation, I like Dexcalibur and House, depends on the situation. MobSF will do it as well. This is really only preferred choices. For file monitoring or shared preference monitoring, remember that, that monitoring tab in House, it was really pretty awesome. That's why I really recommend that one. If it's for monitoring lots of different APIs, then MobSF is probably a better choice because it will automatically have live monitoring of tons of APIs. Also, this is really neat if you have a malware which is doing some anti-reversing. Well, you have their scripts automatically for debugger bypass, routing detection bypass. You can use those just immediately. Of course, you can do it again with Dexcalibur in House, but here it's kind of a little bit more immediate, right? If you want to hook a specific method, whatever, but something which is not like standard so that you would have in all samples. Well, I like Dexcalibur because you can just search in the sample for the method you want to hook and probe it on, and I find that really simple. And of course, finally, for static analysis, well, you have obviously Quark and MobSF. It really depends. Both of them have view things a little bit differently. The way Quark displays crimes, so malicious behaviors, is really pretty interesting. So I would really recommend to run it when you are starting your reverse engineering to understand where you have to focus on. So this is the full matrix there. Now, if you're using you want even more advanced features, like advanced features, well, basically, if you are able to do it with a Frida hook, you can probably do it with Dexcalibur, House, or MobSF. But if you can't do it with a Frida hook, well, too bad, you won't be able to use the tools. Anyway, even if you can do it with a Frida hook, if it's really an advanced feature like native unpacking, native anti-reversing, probably you'll just be better off directly using Frida with your own hook, your own server, your own client, and see what happens, okay? The tools aren't really going to help you out there in those cases, but this is really advanced cases that we fortunately don't encounter that much in malware yet. But if you are doing just standard unpacking, standard deobfuscation, then really the tools, Dexcalibur, House, and MobSF, they're really awesome. You should use those, it will save you time. And that's all for this talk. Thank you very much for your attention. Well, you've got my contact info there, and I am not sure yet if there's gonna be a question and answer session after this presentation. If there is, I'll be very happy to answer your questions. Bye-bye.